Hi everybody, Professor Gusimi here. In this lecture, we're going to be going over some of the elements of the course syllabus, the class more generally, and I'm going to take some moments to highlight things I'd like you to pay particular attention to throughout the rest of the semester. So first is the course schedule. I want to first say that the materials for this class are going to be released roughly once a week. I'm going to aim for Mondays, but I don't want to promise that we will always have things released on Mondays. It could be a Tuesday some weeks, maybe some weeks it'll be a Thursday. But in general, we're going to aim for releasing the course materials once a week on Mondays. There's really three major topical areas we're going to cover in the class that are represented by the three columns you see in front of you. The first is the front end, and you can see the front end discussion includes obviously our introduction to the course, a discussion. I mentioned this a little bit in the introductory video, but I want to highlight again some relevant elements of my background more generally for this class. I'm an assistant professor here at Michigan State University. I'm also a former NIH data scholar, a founder of a startup company, and was a director in industry before becoming a professor here at MSU. And so in this class, you're going to see a perspective on web application development that will touch those different roles, the academic, the government, the startup, as well as the industrial sort of angles on this. I'll do my best as we go through the class to try to highlight and give examples from each of those sectors as it pertains to either my personal experiences or to things that aren't directly within my personal domain of experience, but I think are useful or informative for you to know more about as you undergo your own journey in web application development. At MSU, I have the pleasure and honor of running the Human Augmentation Artificial Intelligence Laboratory, where web technologies are definitely an important component of what we do because we're developing systems that combine human and machine intelligence to solve problems that neither humans or machines can solve as effectively alone. And so if you want to have a human in the loop somewhere, you have to think carefully about how you communicate information to people. And obviously the most ubiquitous communication platform or technology are all built on the World Wide Web. So this course is going to introduce you to tools and techniques for web development. And my hope is that by the end of the course, you would be able to go and deploy your own web applications, and that these web applications could be accessed by any person anywhere in the world. If you become a millionaire and you want to write me a kind note later because your startup becomes a big deal, I would welcome those wonderful notes. I hope, if nothing else, this gives you the first step in your journey towards learning how to build deployable, scalable web applications. And we're going to try to distill that knowledge through covering 5 topics that I'm showing there on the left. The first is, how does the internet work? And what are the key technologies that are used to create it? This is where we're going to try to distinguish between, what is a server, what is a client, what's the internet, what is a router, what is a database, what is a switch, all of the nuts and bolts, the key pieces of the internet that are not necessarily important as you create the simple version of your application per se, but are actually phenomenally important for you to understand if you want to scale and distribute these applications later, or if you want to choose, for example, the appropriate cloud service provider. The terminology there, the lingo is important for you to know as you come to deploy and scale your applications in the future. The second thing we're going to be speaking about to help you obtain that mastery are these visual components of web applications. That's the front end. Okay, so that's HTML, it's CSS, it's JavaScript. It's a bunch of other technologies as well, but those are the 3 we're going to be focusing on in this class, because if you obtain some mastery of those, a lot of the frameworks that you would use subsequently, such as React.js, are really built. They're libraries that are built on top of these core technologies. So your ability to understand and work with the core technologies will make it easier to understand the secondary technologies built on top of them. The third thing we're going to be speaking about is the computational and analytic components of web applications. That's what the backend is. In our case, as I mentioned, we'll be using Python Flask, but the backend also includes the database technologies, the way that the servers are configured, and a whole host of other things. So we'll be speaking about those and the considerations that you should use when building them. Speaking of databases, we'll also touch on how to use databases to dynamically both capture and act on data. If you think about many of the technology companies or services that you enjoy, whether that's Netflix or YouTube or Google or Amazon, they're very data intensive operations, right? Google has to store those YouTube videos somewhere in some kind of a data format. Amazon keeps information on what you've ordered when in a database somewhere. I mean, even financial institutions are keeping all of their records in databases of some kind. And so we're going to be spending some time talking about how to use information in databases dynamically to make intelligent decisions for your web application. And then lastly, to sort of close the loop on this, once you understand how the internet works, the visual front end, the computational back end, and how databases play a role in this, we're going to try to tie it all together by speaking about hosting, management, deployment, securing, and scaling those web applications across the globe. Actually, to facilitate this last point, I'm really happy to share that in this class, for those of you that are officially enrolled, you will be getting access to $50 in cloud credits from Google Cloud. And that's going to allow you to have throughout the semester some hands-on experience actually taking these things and putting them out in the wild for people to touch and play with. That's really great. And I'm actually very excited about that because I think when you are done with this course too, you can use the exact same kinds of scripts and know-how that you've developed in this class to go launch web applications on your own, or for your employer or your parents or whoever else you want to deploy them for. So with regard to the way that the content is delivered in this class, you've probably already figured out that it's asynchronous because you're watching these videos on YouTube, but I think it's worth me stating formally that all the content in this class is asynchronous. So even if you're not officially enrolled in the course, don't worry, you're not going to miss out on anything as long as you're watching the YouTube video series. In terms of content, we're aiming for about 2.5 hours of content a week, and roughly half of that will be tutorials. So that's going to be me opening up a terminal and a development environment and showing you as I do some live programming what the consequences are. And the other half roughly is going to be lecture style content. So slides like this, where I'm going to try to help you understand theoretical concepts that are maybe best illustrated, not through code, but through visuals. Okay. Just to make things concrete, an example of that might be the HTML document tree. So a document tree is a hierarchical representation of the elements in an HTML document. And I've got a very small HTML document there on the bottom left-hand side of the screen. You can see it says HTML, followed by a body, followed by an H1, a P, and then we close out the body in the HTML. And if some of this looks confusing to you at this stage, don't worry, because we're going to go into it. This is just an example to sort of give you a taste for what the theoretical components of these lectures are going to look like. So if we wanted to explain how this document tree works, what we would do is we might illustrate it as we are on the right-hand side with respect to the hierarchical organization of the content. The body you can see is above the H1, P, and P tags, and the text is nestled underneath each of those tags. And what a document tree allows you to do is have a hierarchical representation of these elements in the HTML document where each element is identified by its relationship to the other elements. So, for example, this body tag that I've highlighted here has some children, right? Elements that show up under it in the hierarchy. And furthermore, it has a first child, that's the H1 tag, and it has a last child, which is the P tag. Here, the last P tag that has the 2 embedded within the text. I bring this up because oftentimes this is important when you want to understand the way certain packages are written, or when you want to use some front-end tools, including JavaScript, to navigate HTML documents. They will use lingo like this. And so as part of the theoretical lectures, we will be teaching you these things, not only so that you're familiar with the lingo, but so that when it comes time to programming, you're able to do it without any challenges. We're going to be doing both a theoretical as well as applied component in this course and in the lectures specifically. And when we're going through the tutorials or applied component of this course, you're going to see a screen share that looks something like what you're seeing there in front of you. I will have a text editor open. I'm going to use Sublime 3. You can use another text editor that you prefer, whether that's PyCharm or Atom or whatever your favorite one is. And I will have sort of my screen split so that I can edit the code needed to build the web app and then live see those changes on the right-hand side so that we can start to develop sort of an intuition for how the code on the left-hand side impacts what we see on the right-hand side. In terms of your grade in this class, it's really determined entirely by the work that you do at home. So everything is homework to some extent, but there's a couple of nuances in the structure of those homeworks. The way to think about it is that there's 4 classical homework assignments. These are things where you'll get a lot of structure from and guidance from the lectures and tutorials that will sort of help you get those done. You'll have a longer time window to accomplish them. That's assignments 0 through 3 that you see on that assignments table on the right-hand side. And what those assignments are going to take you through is the first one, which is actually going to be coming due very soon, in less than a week, is setting up your development environment. The next one will be building the front end of your personal web page. The one after that will be building the back end of your personal web page. And finally, we will be enabling real-time event-based communication on that personal web page you do. Now, these are just the high-level assignments goals. There's going to be significantly more detail surrounding each of these assignments, and I'm going to take you through the course GitLab repository here in a minute to give you some more intuition and insights to how you'll access those requirements in a minute. I did want to show you, though, this high-level overview as well as sort of what each of these assignments is worth. You can see that the first 4 assignments, that's 0 through 3, are worth 65% of your total grade. And then what we have at the end of the semester is this course exam. Now, the course exam is also take-home, so I'm not going to sit you down in an examination hall of any kind. You're going to be given a task to perform that will test your knowledge of everything you learned in the class, and you're basically just going to have a shorter time frame in order to implement and submit that. And obviously, it will be doable within the time frame that we assign you. Quick note about your overall grade in the class. On the left-hand side of the screen there, I've got some information on our grading policy and scale for the class. So I've got the percentage numbers, ranges rather, that correspond to the ultimate grade that you will obtain in the class. And I want to make a couple of important notes here about both the grading policy as well as the assignments. With respect to grading, if you notice an error in the grading of your assignment, we'd like you to let us know about that within 48 hours of you getting it. We're doing this because as a teaching staff, there's many of you in the class, and it will not become tractable or feasible for us to take lots of requests to relook at your assignments if you ask at the end of the semester all at once. And so to help us pace out challenges or issues that you might have if you catch something that looks wrong with the way that your assignment was graded, then you'll need to let us know 48 hours from the time that you got your graded assignment back. With respect to these assignments on the right-hand side that I'm showing, and all this information, by the way, is going to be available on the course webpage too, but I'm going over it verbally anyway here. You can see that we have a due date for each of those assignments. I wanted to note that all the due dates here are before midnight on that day, and that the rubrics that describe how we will be doing the grading of these assignments are going to be made available to you so that you know what we're looking for as we grade your assignments, and it's transparent. Last thing I want to mention is that although there are solutions to the assignments, I will not be posting those solutions at any point during the course. Now, when we're going through this class together, I'm not going to expect a huge amount of background knowledge from you. There's some small things we're going to expect around basic proficiency with Python, knowing how to do basic Git commands, things like that. Things you should know as a senior in computer science taking this class. But we are going to expect a lot of integrity from you. That is to say, I'm going to do everything I can to support you in this class, but I'll need you to be professional, honest, and on time with me. All of our assignments are going to be submitted through the course GitLab repository, which I will guide you through here momentarily. And all the code that you submit there has to be functional. If the code is not functional, you will not receive credit for that submission. Similarly, if your assignment is submitted late, it will receive no credit. That's a 0. The only exception to that is if you've obtained prior written permission at least 48 hours in advance of the deadline. I understand emergencies come up. If those circumstances arise, we can have a discussion about it. But the general course policy is if you need an extension, you're going to have to ask for it in advance, not the day before the assignment is due. If you do have any special needs or circumstances, of course, I'm happy to work with you and have a discussion about that. But I would like you to let me know about those special needs and circumstances in this first week of class, not, for example, when the first assignment comes due or in finals week. You need to communicate those things to us early so that we can sort of set up the accommodations accordingly. There is going to be $50 in cloud credits, as I mentioned, that are made generously available through the Google Cloud program. And this should be sufficient to handle any and all costs associated with hosting your web application on the cloud for this semester. However, I'm assuming that you're going to use these Google Cloud credits for this class exclusively. If you, for example, get really excited and spin up some other web applications, or you have some other web applications running and you decide to apply these Google Cloud credits to that application, your credits might run out sooner, in which case you will bear the responsibility to come up with the payment method to cover the rest of the course-related cloud expenses. Last thing I want to mention here, if you engage in academic dishonesty, you will receive a failing grade in the course. Okay, as I've mentioned a couple times already, the materials, questions, submissions, everything is basically done through the course GitLab site, and you can access this GitLab through the following URL I'm showing at the header of this slide. So gitlab.msu.edu/CSE477-spring-2022. If you do decide that you would like to speak with me, again, I'd be delighted to chat with you. But there is a decorum I would like to request of you here at the beginning of the semester. First is that you please email me at my MSU address. I have more than one email, but if you're going to get in contact with me, please contact me at my Michigan State University address shown here. And please include CSE 477 in the title of the email. Also, please describe the problem that you would like to discuss with me very specifically so I can help you, and provide 3 options that will work well during regular business hours if you want to find a time to chat. On the right-hand side of the screen, I'm showing you an example email from another class that I taught. All right, so you can see here I've got the course number in a bracket, I've got the title specifically that I want to speak about, and I list 3 times in here that I'm available to have a chat. So if you send an email to me like this, we can quickly get to the point of having a meeting, and I'll know what it is that you're struggling with for us to discuss. What I'd like to request is that you do not send emails like I'm showing on the right-hand side there. That is, please don't, use a vague subject like just help with course, because I won't know which course necessarily you want help with. Please don't be vague about what you're struggling with. So if, for example, assignment 3 was giving you challenges, try to be specific about what within assignment 3 is giving you challenges as opposed to mentioning the whole assignment. And please don't forget to include times when we can connect so that we don't have to spend as much time scheduling and can spend more time meeting and chatting.